Welcome to this in-depth discussion. Today, we're going to examine the data in front of us, focusing on the connection between diet and brain nerve health. This is a link that many people might overlook. The food you eat every day actually affects your thinking, memory, and long-term brain health. This is a really important issue. We often hear about paying attention to diet for weight and heart disease, but we rarely think directly about its relationship with the brain. However, the brain, our body's central command center, is incredibly sensitive to what we consume. So, our goal for this session is clear: to dig out the specific pathway from which diet affects the brain from the data we provided, and also to look for some practical brain protective strategies. Many people truly don't realize that a seemingly insignificant eating habit might be secretly damaging our most valuable asset, the brain. Let's dive in. The data seems to suggest that the problem often starts with a state called chronic low-grade inflammation (LGI). This sounds a bit technical, but we can imagine it this way. If you constantly eat processed foods that are high in oil, sugar, and so convenient but unhealthy, it's like lighting an invisible small fire in your body that's slowly burning. Is that right? Absolutely. That's an excellent analogy. This small fire burns even more fiercely, especially in cases of overweight or obesity. The data mentions that fat cells aren't just sitting there quietly. They secrete pro-inflammatory signaling molecules, like IL-6. This not only causes inflammation throughout the body, but can also interfere with insulin function, leading to potential problems with energy metabolism. It's like the body's alarm bell has gone off, and this internal alarm somehow directly affects the distant brain. How does that connection work? That's the key point. This inflammatory beacon fire, so to speak, spreads all the way to the brain. It directly impacts the brain's own immune cells, called microglia. Their original job is like a patrol unit, clearing waste and protecting the brain, a guardian force. However, the data says chronic inflammation activates them. Activation sounds like a good thing. Shouldn't the guard be more effective when activated? In this context, the activation might cause them to turn dark. That is, they were originally protectors, but after being chronically and persistently overstimulated by inflammation, they start to go rogue. They release more inflammatory substances, and harmful reactive oxygen species rise. The result is that they turn from guardians into self-destructive invaders. Wow, the guard turns into a traitor. This might sound a bit abstract, but the data refers to animal studies where rodents were fed a high-fat diet. After just 12 weeks, only 12 weeks, the inflammatory markers in their microglia significantly increased. That's fast, only 12 weeks. That's much quicker than I imagined. It means that maybe after just a few months of an unhealthy diet, changes are already starting in our brains. What happens next? Does the brain's energy supply also run into trouble? The data seems to mention mitochondria, the cell's power plants. Precisely, the brain is an extremely energy-hungry organ. It relies heavily on mitochondria to stably provide ATP energy. But imagine if there is constant inflammation and oxidative stresses, like these power plants are constantly under attack. The result is, first, energy output drops. The brain might suffer from a power shortage. Even worse, these damaged mitochondria actually produce more reactive oxygen species. They cause their own trouble. It really sounds like a snowball effect, getting worse and worse. And the data mentions something even stranger. Damaged mitochondria release their own DNA. What's that about? This mechanism is fascinating. You can imagine that if a power plant explodes, its debris flies everywhere. When these mitochondrial DNA fragments escape into the cytoplasm, our cells interpret them as a danger signal and alarm. Exactly. This signal then further triggers a stronger inflammatory response. The data mentions that an inflammatory alarm system called an LRP3 is activated by this signal. Now, if we connect this to actual diseases, the data note that in the brains of patients with conditions like depression and Alzheimer's disease, mitochondrial function is visibly impaired. This strongly suggests that a crisis in the brain's energy supply is likely a core factor in the development of these diseases. Think about it. If the command center runs out of power, all its functions are likely to gradually shut down. The chain reaction of damage doesn't seem to stop there. The data says the next victim is the brain's logistics manager, the astrocytes. I hear they are incredibly numerous. responsible for supplying nutrients to neurons, recycling important neurotransmitters like glutamate, and maintaining the blood-brain barrier. They sound super important. Indeed, astrocytes are absolutely critical logistics personnel in the brain. But consider this. When microglia are causing inflammatory trouble and mitochondria are failing to supply power, this logistics manager also malfunctions. They might lose their original function as supporting neurons. And in some cases, the data suggests they may even atrophy. Atrophy that would have a direct consequence, wouldn't it? Neurons might starve. Yes, they might be cut off from supplies. Furthermore, as you mentioned, glutamate is an excitatory neurotransmitter. If astrocytes can't recycle it properly, too much glutamate accumulates and becomes toxic, poisoning the neurons. Thus, the brain's entire chemical communication system can be thrown into chaos. So, the entire pathway becomes clear, starting with an unhealthy diet, which triggers chronic body inflammation. This fire then spreads to the brain, turning microglia from guardians into enemies, followed by the crippling of the energy factory mitochondria. And finally, the logistic manager astrocytes also fails. This whole process significantly increases the risk of various neurological disorders. The examples cited in the data are genuinely concerning, such as Alzheimer's disease. Yes, in Alzheimer's, we might see astrocytes losing their supportive function, while microglia are fanning the flames of inflammation around those abnormal proteins, the plaques we often hear about. The ultimate result is massive neuron death, leading to severe decline in memory and cognitive ability. Is stroke also related to this? It is. Chronic inflammation itself damages blood vessel walls, increasing the risk of stroke. Moreover, if a stroke does occur, those overactivated microglia might even extend the range of brain damage, making things worse. And even depression and bipolar disorder might be linked to this pathway. That's quite surprising to me. Research in this area is growing rapidly. Possible mechanisms include insufficient brain energy, the mitochondrial problem, reduced neurogenesis in key brain regions like the hippocampus, and the possibility that inflammatory factors can directly interfere with the neurotransmission that regulates mood. Studies have indeed found that inflammatory markers are often elevated in the blood of depression patients. Even Parkinson's disease, multiple sclerosis, and epilepsy, the data suggests all may have some degree of connection with this process of inflammation and cell dysfunction. Goodness, the scope of this impact is vast, and the numbers provided in the data are quite alarming. Nearly 40% of adults globally are overweight, and 13% are obese. Furthermore, the risk of Alzheimer's is 2 to 3 times higher in obese individuals. Exactly. Plus, the rat experiment we mentioned, just 12 weeks. This all strongly reminds us that we cannot underestimate the long-term impact of what we put in our mouths every day on our brain. It may far exceed our imagination. Well, we've talked about a lot of worrying things. Let's look at the positive side. The good news is the data specifically emphasizes that we can protect the brain through dietary change, and perhaps even reverse some of the damage. The diet that is highly endorsed by scientific research seems to be the Mediterranean diet, right? That's correct. The Mediterranean diet is currently considered the gold standard for promoting brain health. Its benefits are multifaceted. It helps reduce systemic chronic inflammation, protects mitochondrial function, and fosters a healthy gut microbiome, which we can discuss more. The ultimate goal is, of course, to reduce the risk of neurodegenerative diseases. What are the specifics of the Mediterranean diet? There seems to be a fluid pyramid diagram. Yes, the pyramid is quite intuitive. Simply put, the base, the largest portion that should be eaten daily, is composed of large amounts of fruits and vegetables. The data suggests at least 5 servings a day, and whole grains like brown rice, whole wheat bread. Then, sources of healthy fats, especially extra virgin olive oil, about 2 to 3 tablespoons a day, and nuts and seeds a small handful a day. That sounds very healthy. What about the middle layer? The middle layer is what's recommended to eat regularly. Weekly, this includes fish and seafood, particularly oily. Deep sea fish rich in omega-3, 2 to 3 servings a week is recommended. Legumes, all kinds of beans are good, 2 to 3 servings or more a week. And poultry like chicken once or twice a week. Eggs are also fine a few times a week. And what about the top of the pyramid, the foods to limit? The top is what should be strictly limited. This mainly includes red meat, pork, beef, lamb, suggested not to exceed once or twice a week, and also sweet, sugary drinks, and highly processed foods. These should be occasional treats, to be avoided frequently. My takeaway is that the core concept is to eat more natural, whole foods and limit those that are heavily processed. Besides this overall dietary pattern, does the data specify any particularly crucial nutrients? It seems like many vitamins and minerals were mentioned. Yes, these key nutrients are usually abundant in the Mediterranean diet, and they each play important roles. For example, the main forces for antioxidation and anti-inflammation are vitamin C, vitamin E, and the aforementioned omega-3 fatty acids. You get these from plenty of fruits, vegetables, nuts, olive oil, and deep-sea fish. Then, for maintaining the normal function of the nervous system, the B vitamins, especially B2, B12, and folate are extremely important. They are widely sourced from whole grains, meat, eggs, and dark leafy greens. B vitamins are crucial, yes. Also, immune system regulation is vital, such as vitamin D, which we can get from sun exposure or supplements like fish and egg yolks, and certain minerals like zinc and selenium, which are found in good amounts in seafood and nuts. It seems like there are a lot of different kinds to remember. Will that be too complicated? Actually, there's no need to be overly anxious. I think the key is to grasp the general principle of the Mediterranean diet, eating a rich and diverse diet with plenty of vegetables, fruits, whole grains, healthy fats, and adequate protein. By doing this, you usually ingest most of the key nutrients. Instead of obsessing over whether you're getting enough of a single nutrient, focus on improving the overall quality of your diet. That's a great concept, looking at the big picture rather than just the details. You mentioned the gut microbiome earlier, and the data calls it our second brain. But the gut and the brain are so far apart. How do they influence each other? Well, this is a very hot area of research in recent years, known as the gut-brain axis. Our intestines host trillions of microorganisms and enormous number. Whether this gut flora is healthy or not directly communicates with our brain through various pathways, including the nervous, immune, and endocrine systems. This, in turn, influences our emotions, stress response, and even cognitive functions. Well, that sounds incredible. So, if our gut flora is healthy, what good things can it do for us? Well, a lot. They are like a well-trained internal eye. For example, they can ferment the dietary fiber we eat to produce beneficial short-chain fatty acids, SCFAs. These SCFAs can fight inflammation, maintain gut health, and even affect brain function. They also help synthesize certain vitamins and train our immune system not to overreact, reducing unnecessary inflammation. I see. So, how can we cultivate this vital internal eye? The advice provided in the data is quite practical. The first is to give them ample food. Their favorite food is dietary fiber, so eat more vegetables, fruits, whole grains, and legumes, more veggies, yes. Second, you can moderately supplement with good bacteria by eating fermented foods like plain yogurt, kimchi, and miso. If needed, probiotic supplements can also be considered, but it's best to consult a doctor or dietitian first. Consult an expert, yes. The third point is also very important. Try to avoid damage. Eat overly processed foods and avoid the misuse of antibiotics, as these can harm the diversity of your gut flora. Understood? So, taking care of the gut is indirectly protecting the brain. That's a crucial concept. The data also seems to specifically address the nutritional needs of the elderly. Are there any particular things to watch out for in this group? This is extremely critical because the elderly are a high-risk group for neurodegenerative diseases. Although their overall calorie needs may decrease compared to when they were younger, their requirement for nutrient density is actually higher. Nutrient density. Yes, it means every bite of food they eat must be as nutrient-rich as possible. They shouldn't just be full, they must be well-nourished. I see. Are there any nutrients that the elderly should pay special attention to supplementing? The data highlights a few key areas. The first is vitamin D. Because the efficiency of vitamin D synthesis in the skin of the elderly decreases significantly, potentially by as much as 75% if they reduce outdoor activity. deficiency is very common. Wow, that much difference. Yes. The second is vitamin B12. The elderly's ability to absorb B12 may decline, and some older people may be on long-term medications, like certain stomach or blood sugar drugs, which can also affect B12 absorption. B12 deficiency can affect nerve function, so this needs attention. Also, calcium and protein are very important for maintaining bone health and preventing sarcopenia muscle loss. It is also important to be mindful of drug-nutrient interactions. We just mentioned beer, but also things like certain diuretics can affect the balance of potassium and magnesium in the body. So, it's best to have a doctor or pharmacist regularly review the medications of the elderly. That's a very practical reminder. Alright, now that we've gathered all this information, if we go back to the daily dining table, are there any simple swaps that make it easier for us to start taking action? Yes. The data offers some great upgrade suggestions that I find very useful. For example, for breakfast, you can switch from white toast with bacon and ham to whole grain bread with avocado and a boiled egg, or plain Greek yogurt with berries and nuts. That sounds much tastier. For lunch, you can swap fast food burgers and fries for grilled fish or grilled chicken, paired with plenty of vegetables and a side of whole grains like quinoa or brown rice. That's definitely more satisfying. And for dinner, you can switch from greasy braised meats or fried foods to steamed fish or baked chicken breast, again paired with a variety of vegetables. For the main course, choose brown rice or whole grain options like sweet potatoes or pumpkin. For snacks, trade the potato chips, cookies, and candy for natural fruits, plain nuts, or vegetable sticks dipped in hummus. These swaps all sound very doable, and actually, they seem more delicious and varied. Exactly. So, to summarize the core message from the data you provided, I think it can be condensed into 3 points. The warning: every unhealthy bite of food may be quietly initiating a chain reaction that attacks your brain. Be vigilant. The path of damage: unhealthy diet gives chronic inflammation, gives microglia, churn hostile gives energy factory mitochondria. Failure gives logistics astrocyte breakdown. This sequence increases the risk of neurological diseases. The countermeasures: embrace the Mediterranean diet pattern, ensure adequate intake of key nutrients, and take good care of your gut microbiome. These 3 are powerful weapons for protecting the brain. Our brain is truly priceless. It stores our precious memories, shapes our personality, and controls our joys and sorrows. We must not let unhealthy eating habits erode bit by bit. You're right. The data also encourages us that it's never too late to change. We can start with our next meal by choosing more natural, fresh foods and trying to implement the principles of the Mediterranean diet and good gut care. Of course, a healthy lifestyle is holistic. If you can combine these changes with regular exercise, adequate sleep, and stress management, the effect will be the best. Remember this, friends: every bite you eat today is a deposit into your cognitive bank for tomorrow. That's a wonderful way to put it. Finally, I'll leave you with a question you can reflect on. Beyond the diet we discussed today, what are the seemingly insignificant habits in your life do you think might also be quietly impacting your brain health and long-term cognitive function? For instance, how well do you sleep? How stressed are you lately? Do you interact and socialize frequently? And, thinking more deeply, how do these factors interact with your dietary choices to truly shape your current brain state? This might be the direction you can continue to explore.